Hello there everyone, I'm uxwbill, and before you sit down and take in the video that you're about to watch featuring this product review of the Ames Instruments DM1000 Multimeter, I'd like to let you know that it's actually been subject to some revision over time. Most everything that you're about to watch was recorded to video in January of 2018, and I really had plans to be the first, if not the most definitive reviewer of this product on YouTube. I would imagine that crown has probably slipped away. But I was actually contacted by Harbor Freight customer service personnel and product design managers in regard to my commentary on this product in a review that I wrote on their website. They have not seen this video before any of you have had the opportunity to watch it. And I want you to know that although they did send me a replacement multimeter free of charge with revised components to address some of the concerns I expressed in my written review, that they have in no way whatsoever compromised this review. It's not a sponsored review, there's no product placement. I am still going to tell you how I honestly felt about this product. So with that said, please sit back and enjoy. I'll be here when you're done, and I eagerly await your constructive thoughts about this video and the product. Let's go ahead and start with a look at the box. Right away I will say that the Ames Instruments box is a great deal flashier than the Centec box. And the only reason the Centec box is actually still around has to do with a rather serendipitous discovery. That's your word for the day, serendipitous or discovery. You can take your pick, or you can even choose both. This was actually wedged in the bottom of the recycling bin, so somehow it never managed to escape. And as you can see, it's much less exciting than the Ames Instruments box. It's also a great deal more subdued in terms of color scheme. And pretty much right down to brass tacks, where the Ames box is a great deal more descriptive, and we won't go into great detail on most of this because it's really not very interesting, and it's not like you can't see it for yourself at a Harbor Freight store if you happen to have one, or presumably even on their website when this product happens to show up there. But if you're interested in looking at something on here, you can certainly pause the video wherever it's appropriate. Here we have the safety ratings, Category 4 up to 600 volts, Category 3 to 1000, the name brand, a description of what it is, a little more blurb about that, and then it tells us about some of the features. I'm not sure that I really agree that this is the kind of thing a professional multimeter user would want to carry around, but Harbor Freight would like you to believe that it is. Tells us that it's capable of making AC and DC voltage measurements up to 1000 volts. I don't know that I would feel at all safe doing that, even though they claim that this has been tested by a reputable independent laboratory, ETL Intertech, which after reading about them for a while, it's my understanding that they are basically equivalent to tests performed by the Underwriters Laboratory. And if you're not familiar with either one, you can read about them online. Basically, those testing laboratories make sure that a device behaves in a safe fashion and that it meets its published specifications. And in the case of UL, they actually test devices to the point of destruction to find out what they will take. One of the most interesting features in this block of descriptive text is the low Z, low input impedance setting. Some multimeters have this, most of them do not. Basically, a good example of its use would be to imagine that you have several wires run through a conduit of some kind, and let's say that 3 of the 4 are actually carrying electrical power. What they can do, what can sometimes happen, a phantom voltage can be induced on any idle wires inside the conduit. So if you take a multimeter, which is normally a high impedance or high resistance instrument when it's measuring voltage, you can be led to believe that there's a significant voltage there when in reality it's nothing. If you loaded it down to any significant degree, it would disappear or even be greatly attenuated. And that's exactly what the low Z measurement setting does. It greatly reduces the multimeter's input resistance or impedance figure, usually from 10 megaohms down to about 3k ohms, in the hopes of loading down an induced voltage so that you'll see it's not really there. Down at the lower left-hand corner of the package, you can see a series of icons indicating all the major test ranges. There's the ETL Intertech badge and a number. Again, they reiterate the maximum supposed safe specifications. There's someone here on YouTube by the name of Joe Smith who tests multimeters in varying ways. He drop tests them. He does a number of tests on their front ends to determine how robust they are. He's also lately been doing switch cycling tests to determine how well various multimeters stand up to many years of use. Only it's done over an accelerated period so that you can find out in a much more timely fashion. I'm not really sure that I agree 100% with his testing methodologies, but maybe at some point he'll get his hands on one of these meters and decide to run it, and we can all see for ourselves how well it actually does. I'm not equipped to do the kind of things that he actually does, and I think it would be a good test because Harbor Freight repeatedly indicates that this meter is ruggedly built and certified safe. Now, if they're willing to say it's certified, I hope they're willing and able to put their money where their mouth is. We'll see in a little bit. I do plan to pop the cover open on this thing just so you can get a look at the internals. There's some pictures on the side. They show it hanging from a breaker panel. It does come with a magnetic strap. The meter itself does not have a magnet built into its casing, unlike some. The specifications are reiterated on the side. They also show you what you get with the multimeter, although absent from this picture are the included batteries. Yes, this time batteries are included. They're just the cheap carbon zinc batteries that you might imagine them to be. They also don't show you the strap with the magnet on it, but there is the carrying case, the Type K thermocouple, the Type K thermocouple adapter, and a set of test leads. On the back, beyond the manufacturer, or at least the distributor information, because you can be sure Harbor Freight didn't actually make this thing. They're just distributing it. We'll find out who makes it a little while later in this video. Like I say, I'm reshooting this, so I already know and already have developed some opinions about this, but we'll try to give it as fair a shake as possible. Only a few of these models mentioned on the back have actually appeared. The only ones that I could see were the compact and the HVAC electrical, the DM600 and the DM1000. They did not have the DM1010, and they did not have the pocket, or DM300, and I suspect it is the DM300 that's probably going to replace the little DT830 freebie meters that Harbor Freight is apparently clearancing out. But these are the specifications for each one. You can pause the video to read that if you would like to do so. We're not really going to go into it here other than to say that the claimed capacitance testing range on this thing, which is 66 millifarads, is really quite impressive. I've never seen another multimeter that could claim to test a capacitor that large, and I can't imagine this thing would do it very quickly. But they claim it can do it. Unfortunately, I don't have anything that large to actually test it with. I also find it interesting that repeatedly on the box they indicate there's some sort of anti-theft alarm protection. Not only have I never actually seen any of those like Sensormatic style alarms in any Harbor Freight store I've ever been to, I did not find anything in this box that indicated it was in any way alarm protected. Not that I am suggesting you shoplift, although on your own head be it. Obviously I'm nobody's idea of a tattletale, but there are just certain things you really shouldn't do. So that's the box, that's everything you get there, and this is what's actually in it. Now along the way we'll be making some comparisons with the P98674 Centec multimeter that I bought a couple of years ago. I've been very happy with that little multimeter, although I've bought several others since then that have differing capabilities. For what its capabilities are, it seems to do very, very well. I've been very happy with it. The only thing I've ever had to do to it, and admittedly this is kind of unfortunate, it began to behave erratically with regard to the mode selector switch around the two most frequently used settings, which are to say the voltage testing ranges as well as the ohms, continuity, diode, and capacitor test. Sometimes what would end up happening, the multimeter would fail to power up properly, or it would end up rebooting itself. And when it failed to power up properly, what it usually did, the temperature display would come up perfectly well, everything would be working there, but the main meter display would either show up as incorrect indicators, it would fade to blackness very quickly, although I shouldn't say fade to blackness, I should say fade to gray, I guess, because that's the color of the substrate. Obviously these characters are only black when they're illuminated, but suffice it to say they did fade to nothing. Sometimes the meter would restart itself if it was toggled between these two ranges. I did have to effect a repair, but it was very easy to do so. I simply took this apart, revealed the selector switch mechanism, and sprayed some deoxit onto it, rubbed it around, dried it up as well as I could, put it back together. It's been fine ever since. I don't know if other examples of the 98674 have that problem, but it's certainly something worth noting. I don't consider it unsafe to use, but then again, I typically take at least 2 meters to any job that I have in mind to do, just in case one of them does decide to break down or one of them is lying to me. This is still running on the inexpensive Asian anonymous carbon zinc batteries that it came with. It runs on 3 AAA batteries. I actually greatly prefer this to what the Ames instruments meter runs on, which is a 9-volt battery, because the power density of the AAAs, even the lowly carbon zinc ones, are much better than a 9-volt battery. I think even the very best 9-volt batteries only manage about 500 milliamp hours worth of current delivering capacity, and if you load them heavily, you will not get anything like that. On the package, Harbor Freight again makes a mistake with the batteries, although not quite as grievous a one as with the Centec, where they said the batteries weren't included, except they were. They claim that an alkaline battery is in the box, but what you actually get is this Thunderbolt Magnum zinc chloride heavy-duty battery. Very similar to a carbon zinc battery. I didn't even bother with that because I had a much higher quality ever-ready battery sitting around here. So there's the meter itself. There was one other thing I wanted to mention about the box. Of course, I forgot to do it like a complete boss. The most interesting thing to me was the illuminated liquid crystal display. You can see that all the characters here are illuminated, and a couple of things caught my attention. First of all, there's this small group of 4 7-segment indicators. I wondered if this might not be used to indicate temperature, as it was with the predecessor to this meter. Unfortunately, it is not. This only indicates duty cycle and frequency when you're in the alternating current voltage measurement mode or the alternating current measurement mode. I also thought this universal serial bus symbol was highly interesting. It suggested that here again was a multimeter with unutilized data logging and PC communication capability. Unfortunately, the actual display is nothing like that. You can pause the video to see this if you can look past the reflections and glare from the shiny display. We'll try turning on the backlight here. See if you can see some of the ghost entries. The display is almost completely different in terms of its layout from what's shown on the package. Thought that was interesting. Maybe the picture on the package was simply doctored up in a photo editing program of some kind, or perhaps it reflects a prototype that was later cost optimized and the display simplified as a result. Here's the carrying case that you get. I guess this is okay. It feels kind of cheap, and I think it's needlessly bulky. So I have to qualify those things by saying that I have been somewhat spoiled. You see, the 98674 meter did not come with a case of any kind. So I had my mother take a fatally damaged pair of blue jeans. They'd had a tear in a knee or something like that that rendered them useful only as rags and scrap. She took them and she turned them into this awesome multimeter carrier that I actually keep the 98674 in. It's really not any smaller, but it's so much more nicely made. And I would say that even if my mother hadn't made it, although it certainly helps that she did. It's also easy to throw this through a belt loop and keep it with you. Something you can do with the Ames Instruments case, but if you open it up, everything's pointing the wrong way, and it might actually fall out. And since some things just fell out there, here's what's inside the case. You get an instruction manual. Harbor Freight issues their standard and limited 90-day warranty, which I think is a little bit stingy. There's the Type K thermocouple, and although it managed to escape, you need an adapter to utilize it. I'm really not fond of this approach. I prefer a dedicated Type K thermocouple input on a meter. There's a strap that can be used to restrain the meter to keep it from falling out. It works well, but it's almost too tough to make it release. I guess this is where you're actually supposed to put the test leads. You can tell I did that incorrectly. The zipper feels a little bit cheap, and if this is anything like the other cases I've had from meters manufactured by this same company, which we'll get to in just a moment, I wouldn't be surprised if it broke down. Harbor Freight Tools does have the substantial advantage that in most cases they actually write the manuals for the products they sell. So they're written in comprehensible English and are generally correctly written. You'll see that this does actually have the correct illustration for the display panel that's present in this meter. And while we're looking around in the manual, I'll see if I can find the accuracy and specifications here. They do indicate that one should calibrate this meter every year. I don't think most people are going to do that. And I'll show you why in a little bit, though you certainly could if you wanted to, and you had the necessary tools to do so. Here are the measurement ranges and specifications. Again, we'll try to get the Handycam to focus. I have no idea why it's being such a prune about that as of late. I hope it's not trying to suggest that I am about to buy a new camcorder, because I really don't have the money for that. So we'll go down a little bit here. And again, any of this that you're interested in, you can pause the video. There are a few curiosities here. I noticed that the frequency counting range, although it sacrifices some degree of accuracy, when you're actually measuring voltage or current, it goes clear up to 10 megahertz. Whereas when you're not, it's much more limited than that. Right there it is, frequency. Frequency accuracy. Voltage mode, 1.5% of reading, plus 5 digits. In the dedicated hertz measurement mode or frequency measurement mode, it only goes up to 10 kilohertz, and I stand corrected. I thought it only went to 10 megahertz, and I think it says that somewhere on the box. So there's a discrepancy there. But in the voltage mode, you go clear from 66 hertz, which is an odd minimum, to 66 megahertz. And that might be a bit of a problem if you wanted to measure a 50 hertz or lower alternating current source, as you might if you live outside a country where the 60 hertz power standard is the nominal one that's in use. But since Harbor Freight is a United States only chain, I don't think most people are going to be doing that. At least not with a Harbor Freight branded version of this meter. Here's the meter itself. I'll tell you that I think the rotary control feels kind of cheap. I certainly think that the one used in the 98674 meter is actually of somewhat better quality. I still wouldn't say it's the best you can buy. And after mine's had some use, the clicks are nothing like as decisive as they used to be. But they're certainly there, and the control works well. Another feature of this meter that I really like, although it could be argued that a professional wouldn't actually need it, are the illuminated and alarm-equipped input connections. If you hook this meter up incorrectly, it will make a beeping sound to indicate that you're about to do something you might regret. And everybody can make mistakes. Especially someone who's just starting out. That feature is unfortunately missing from the Ames Technology DM1000 model. Another feature of the 98674 that I really like, although here again this is in disagreement with Harbor Freight's manual for this multimeter, when you turn the backlight on the 98674, it stays on continually. And every example I've come across is set up this way. Until the multimeter's automatic power off kicks in, that backlight will stay on, which is really, really great. Sure, it runs down the battery a bit more quickly, but when you need the backlight on a multimeter, you really need it. And in my opinion, at least, it's not the kind of thing that you want to be fiddling with when your concentration and certainly your hands are somewhere else, especially if that location happens to be hazardous. I will say that the backlight is quite good. You may actually find yourself using it more on this multimeter than you would others. It looks better on camera than it does here in real life. I'll turn the backlight off just so you can see. The digits look good in dark, but I have found in certain room lighting situations, such as when I had this up in the dining room earlier, where we're using LED light bulbs, that the unilluminated display was really quite difficult to read. And I don't know if it was simply a matter of the two driving frequencies, the ones from the LED lamps, as well as the display multiplexing that's done by the microcontroller inside this meter. If the two were simply beating against one another in an awkward way, making the display even harder to read, but it's certainly worth considering. And in this one, the display backlight only remains on for 1 minute, so I think that definitely counts against it. Here are the test ranges on the dial selection control. You can see that some of them are actually combined with others. You have voltage and frequency. You have a dedicated frequency range, temperature in degrees Fahrenheit and degrees Celsius. And unlike some meters, there is actually a sensor built in. See, there with the backlight. So you don't have to hook up a temperature probe if all you want to do is gather information about the ambient temperature. You will, of course, have to give the meter time to acclimate. There's the ohms resistance setting. You can toggle between Audible Continuity, which kicks in and kicks out around 50 ohms. The diode testing range is combined with that, but the capacitance testing range is not. You have a microamp testing range, a milliamp testing range, and of course an ampere testing range. If I didn't overshoot it, goes all the way up to 10 amps. And then finally you have the low Z voltage measurement mode, which again is used to solve the problem of phantom voltages on wires that could otherwise fool you. You also get a set of test leads with this. Only one of them seems to be around here right now. The other one probably fell on the floor and is going to get a stern talking to later. I think these are entirely of acceptable quality for anything that this multimeter is capable of safely measuring. Unlike the ones that came with the 98674 and revealed who its manufacturer actually was, these don't say Mastech on them, they say Ames. They're certainly no worse than any other decent quality multimeter probe I've ever seen, and they have these little sheaths here on the end that you can actually remove. These help to avoid short-circuiting adjacent connectors and potentially causing an explosion or giving yourself a heck of a surprise, and hopefully eventually taking out some kind of protective circuit device or another. Unless, of course, you happen to be really, really unlucky, and then something might actually explode in your hands, and we don't want that to happen. That just would not be good. Seemingly, in order to meet the Category 4 specification, these tip covers do have to be in place. So with all of that discussed, let's take a look inside the multimeter. It's here that I'll lodge another complaint with the design, something that really doesn't thrill me. The battery cover and the meter's kickstand are combined into one fairly awkward assembly, and unfortunately they don't seem to be very well made. Getting the kickstand to latch back in place, it's under a fair bit of spring tension at the end of its travel, and I can only see that potentially breaking years down the road. This battery cover is also a point of weakness, and unfortunately, in the case of this meter, it already has broken. You can see right there how it pulls free. And this meter has only been dropped once while it was actually in its protective carrying case onto the linoleum in the kitchen floor. Meanwhile, this 98674 meter, which has been just about everywhere with me, has fallen onto concrete multiple times. It's fallen from 6 feet up. It's fallen from 25-foot up ladders. Every time it's lived to tell about it. It's even fallen down a couple of different flights of stairs a few times, and every part of it is still intact. Nothing's broken. Everything works just the way it's supposed to. Of course, the kickstand, which is also much harder to deploy, does actually work fairly well when the meter is just resting on it. It's not so lightweight that you can't turn the mode selection knob or push the buttons and have it fall over, unlike some other meters. That's also not a problem for the 98674. Really, the thing I would have liked to have seen Harbor Freight do was take this basic design and simply add the true RMS alternating current sensing capability to it. Then, in my opinion, it would have been an absolutely perfect multimeter for a lot of people. Maybe professionals would look down their nose at it, but I have certainly used it. There's the other meter lead. In my HVAC classroom lab environment, where it has stacked up against some very tough competition, including flukes and UEIs and similar things. I don't know that a real professional would use that one, but I certainly did, and it never once gave me any trouble. And this is what the Ames Instruments DM1000 digital multimeter looks like inside. During my first revision of this video review, I started out fairly early on by hypothesizing that this multimeter was probably yet another example of something based on the DreamTech International DTM0660L all-in-one true RMS sensing multimeter on a chip. And unlike a lot of cheap and cheerful chips, that one actually seems to work pretty well, and it shows up in all manner of multimeters from the cheap to the expensive. It's actually sitting right over here. Has a little clock crystal all its own over there. And as is common with any of the multimeters based on that chip, there is an EEPROM over here that stores the various operating parameters, such as the calibration data, the number of counts, resolution, that sort of thing, how long the backlight stays on, which brings to mind the point of calibrating this thing. Unlike a lot of multimeters where there are usually some adjustment trimmers within that you can adjust to calibrate things, this multimeter's calibration process is performed programmatically with precision references. You close this jumper block over here to indicate that you wish to enable the calibration mode, and then, if what I have read about this is actually correct, I haven't actually tried it myself, you supply precision references of a known value to this chip, and then it recalibrates itself accordingly. There's also a dedicated microcontroller in here. This is a Hycon Technology 8-bit, as they describe it, RISC-like microcontroller. I think it has about 60 different instructions. Doesn't really matter a whole lot. It integrates an analog to digital converter that probably for the most part goes unused in this design, since the DreamTech chip can do just about everything and then report on its findings to the main microcontroller. It also has a display driver. I'm not sure why they felt this was necessary, because I certainly have other meters where the DreamTech chip is used to drive a very complex display, including the, what's the term for it? I can't think of it right now, but that ruler along the bottom that shows up on this meter, as well as certain others. I know there's a term for that, but I'm having a brain fart right now, which is unfortunate, but that's how it happens. There's another clock crystal over here for the main microcontroller. Little piezoelectric beeper. You can see some wire leads going off to the backlight over here. There's a little spring that connects with a piece of conductive foil on the back panel of the meter, probably to help reduce problems with interference that would introduce undesired operation. Up here is a thin piece of metal that actually represents the antenna for the non-contact voltage detection. I don't really see anything on this board that makes me say, uh-oh. But it doesn't seem to have been constructed quite as well as it could have been, and it certainly looks like certain things have been added on as afterthoughts. These are the battery connection leads right here, and the soldering on the negative one at least is a little bit sloppy. Over here we finally find out who is the actual OEM of this multimeter, however indirectly. You can see that several multimeter model numbers are given here. This is an MS8251C. That's right, this is yet another Mastech multimeter made by Precision Mastech for Harbor Freight, same as the P98674 before it. And I cannot find much information about that multimeter online. It's not even mentioned on Precision Mastech's website. These fuses that provide protection for the current measurement ranges actually look to have been tacked on as something of an afterthought. I am pleased to see that the larger of the two appears to be an HRC, HBC, that's a high rupture capacity, high breaking capacity fuse. It is actually rated for 1000 volts AC or DC. This smaller ceramic fuse, which is probably also HRC rated, also claims on its end caps to be suitable for use at up to 1000 volts. So, in theory at least it's possible, but again I'm not sure it's really a good idea, and here's why. Again, I'm not an expert on this. There are lots of people out there who know more than I do, but it just doesn't look like there's a whole lot of protection on this board. The only thing I see are these positive thermal coefficient, or PTC resistors. And the way these operate, let's say that you have the multimeter set to the ohms range and mistakenly stick the prongs in the test leads and their prongs into a live electrical outlet. Well, there's going to be an enormous inrush of current, and if it weren't for these PTCs heating up and having their resistance go up considerably, there might be a bit of a bang and you'd probably be in the market for a new multimeter. But I don't see anything in here like an MOV to absorb a surge. I do see that the circuit board has been cut here, probably to help prevent arc-overs between these two connections. I can't really speak to how well spaced the tracks are because, again, I'm not an expert on this subject, but it does look like there is a fairly decent amount of separation between the various test jack connections. So I think this is certainly no worse than any other budget multimeter you're likely to find. But again, I don't think it's fair to compare this to something like a Fluke that will, in most cases, survive an awful lot of punishment while maintaining safe operating conditions for the user and usually continuing to remain functional during such a catastrophic event. If, of course, you plan to take apart your own Ames Instruments multimeter, do be sure to remove the battery cover before you attempt to take the orange plastic holster off. Otherwise it tends to snag, and here again, this thing is just very, very flimsy. You can see one of the two tangs is broken and the other one's a little bit heavily abused. We'll see if we can get that to focus any better. I'm going to be talking to Harbor Freight to see what they have to say about potentially getting a replacement part for this, or even suggesting that they should talk to their manufacturer, Precision Mass Tech, and ask them to improve the design of this assembly, because right now it's just really not very good, and it's a pretty serious dark cloud over what really isn't all that bad of a multimeter. Alright, so for those of you in the audience who are looking for some performance-related specifications and benchmarks and calibration checks and things like that, we're going to start with that now. The first thing we'll do is we'll make some voltage checks. These are all going to start out as low voltage DC, as I have something I did not have when I reviewed the 98674 multimeter, and that is, however inexpensive it may be, a precision voltage reference, or a voltage standard. I suppose you can't expect too much out of such a thing, especially since it's been made from a reclaimed part, but it uses an Analog Devices 584LH, which to my understanding and knowledge is actually an extremely precise reference. Unfortunately, it's not made anymore, which is why it's believed that these things are being pulled off of scrap circuit boards. Maybe they're even being counterfeited. Who knows? But they do seem to work. I have the reference set right now for 2.5 volts. And we get to 2.497 on the Ames meter. So we'll turn the switch off here, and we'll change the jumpers around. And we'll go up to the next voltage in line, which should be 5 volts DC. And again, it certainly appears to be well within specification in terms of accuracy. So we'll make another check here. We'll go up to 7.5 volts DC. Well, something's definitely not quite right there, but I think I might know what it is. I think those 9-volt batteries might be a little bit questionable, so let's get a better set of those down here. I know one of them is well past its expiration date. We'll just try to find out which one it might be. That's a good test, isn't it? Well, that one's definitely a little bit weak. And that one is junk. That one actually has reverse polarity. Okay, that needs to go bye-bye. So we'll get some better ones here. These are all rejects that came out of smoke detectors. Now typically they're replaced every year. But some of these, as you can see, have gone on a good bit longer than that. Probably way too long, in fact. Yeah, those two are junk too, so you know what we'll do? We'll get some. I know there are some good ones up here. These Duracell Quantums were definitely taken out of stuff that did not strictly need to have a new battery. There's 9.06. There's 9.3. So that ought to work a fair bit better than the other one did. I'll get that all hooked up and we'll be right back. Yeah, I definitely should have known something was up there because the pilot light on my voltage standard was nothing like as bright as it's supposed to be. So now we're all hooked up for a 7.5 volt reference. And it's basically right on the money. So we'll go to the final step here. 10 volts is the maximum this thing can output. We'll go up to that and we'll see what it looks like. That's reverse polarity. We'll try to get it right. Although that too is a good test to run because there should be symmetry between the inputs. The values should be equal. And at least to a limited extent they are. So that's the voltage standard. I guess while we're at it we could see, since Harbor Freight mentions that the Ames instruments meter should be calibrated every year, and I think they said the same thing about the 98674 before it. These are not actually the test leads for the 98674. I thought they were. One of them is. The other one's probably on the floor. That brings to mind another bit of commentary about the Ames instruments meter. Its test jacks do not feel anything like as sure as those of the P98674. So we'll ask it for a voltage reading here. 10.06. Again, I'd consider that well within tolerance. We'll step it down here. This should be 7.5 volts again. Let's see about the symmetry. Yeah, it looks pretty good to me. I'd certainly consider that more than acceptable. Going down to 5 volts now. As we try to lose a 9-volt battery here. Yes, I should probably give this thing some more time to warm up and be stable. 2.5 volts. So even though it's been more than a year since that meter was sold and distributed, I'd still say it's well within tolerance. Next thing we'll test are resistances. What you're looking at right now is a resistance substitution box containing 1% accuracy, 1 watt rated resistors ranging from 1 ohm of resistance all the way up to 4 mega ohms. I know that for the best possible test I should be using a much higher accuracy resistor than that, but this is the thing that I could find that just so happened to fit into my price range. I'm not using the multimeter supplied test leads. I actually have some banana plug style leads here, sold under the Hold Peak brand name. These seem to be pretty high quality for the money. I'd say they're worth at least 2 or 3 times the price that they go for. I want to say these went for about $6, and they're far better than the price would suggest. They also allow me to maintain a very low resistance connection to the resistor substitution box or my variable regulated power supply or anything else along those lines. And as you can see, we just have the tiniest little trace of resistance right there, 0.2 ohms. You can null out resistances and voltages on this meter by simply pressing the relative button, which actually switches you over to the manual ranging mode. You can take it back out of the relative mode. So let's throw some resistances at it and see how accurate this thing's figuring is, as well as how quickly it can auto-range and settle on a value. Here's 1 ohm. I actually read a little bit more than that because of the aforementioned resistance in these leads and no doubt the circuit traces of this inexpensive resistor substitution box. So let's kick it up to 200 ohms. It seemed to settle pretty quickly. There's 3K. Now we'll go up to 40K. And again, I'd say it's certainly more than accurate enough. Took a little longer to settle for 3 meg. Let's go back the other way. We'll go back down to 20 ohms. It settled pretty quickly. I haven't noticed a whole lot of overshoot. If anything, it seems to undershoot before it reaches a stable measurement. It did overshoot a little bit there when I went up to 4K. And of course you can add resistances on this box by switching in several at a time. So here's 4 meg. Took it a while to settle on that. That should be around 7, and it is. And we have 9 meg. And finally 1 meg. And here again, if we choose the relative measurement mode, there should be a certain amount of symmetry in the reading when you turn off the resistances. I would say it's certainly more than close enough. Let's try some other voltages. This is a random smattering of digital multimeters attached to my benchtop regulated power supply. The Ames instruments meter is right here, of course, and basically what we're going to do with this test, we'll see how its readings compare to other meters in the group, including this little DT830 cheapie up here, and we'll also see how fast it can auto range. We'll be going from 0 to 30 volts, starting right about now. And the power supply is at the very bottom of its output range. Seems everybody's pretty much in perfect agreement here. So we'll start cranking things up. We'll go up to about half a volt. A little hard to get there even with the fine adjustment control in use. But they all seem to agree with one another, both new and old. Even the little cheapie agrees with all the others, certainly to a more than reasonable extent. I did notice that at the low end of the scale, that the older P98674, although it's rated as having less counts worth of precision than the Ames instruments model, it actually has an extra digit worth of precision down there at the millivolt scale. So we'll go back up to half a volt there. Then we'll take it up to 1 volt. And they're all pretty much in perfect agreement with one another. Take it up to 1.5 volts. The displays on the regulated power supply do read low, they always have. Everybody's within a few counts of everybody else. Even again the little DT830 cheapie. I think the fine voltage adjustment on this has a range of about 3 volts. And there again, everybody's in agreement. 3.16 over here, 1.3, 1.5, 1.3. I'm sorry, 1.13. Slipping decimal points. You can tell it's getting late. Alright, let's kick things up a little bit higher. Go up to 5 volts roughly. And they're all pretty close to one another. There we are at 12 volts. .24 volts DC. Everybody's pretty much in agreement on that. And then we'll just take it all the way up, which is around 32 volts for this particular power supply. So it seemed to pass that test pretty well. Certainly in reasonable amounts of agreement with the other meters that I have. They're not more than maybe 20 counts out from one another on the low end of the scale toward the least significant digits. And it seems that the most error is being indicated by the 98674 as well as the DT830. But for most things, nobody's going to need that much precision. Turn the voltage all the way down to 0, see how long it takes everybody to settle out. And then we'll turn the regulated power supply off. And then, of course, there's the matter of the audible continuity range. A good multimeter typically has not only a latched continuity beeper so that it doesn't sound scratchy while you're trying to make an audible continuity test, but it should also be very, very audible, and it should respond quickly. It doesn't always seem to notice particularly short makes when I was touching the leads together, but I'd say that the results of the continuity test are certainly acceptable, and I think it's loud enough to be reasonably heard in most working environments. Obviously, if you're really in a noisy place, you might want to look for something a little bit louder than this. So now we'll make some AC line voltage tests, and we'll take a look at the true RMS measurement capability. In preparation for the AC line voltage test, I've connected various multimeters to the outputs of this American Power Conversion uninterruptible power supply. All of these meters, except for the Centec 98674, are true RMS responding. We have an Aneng AN8001 there, a Southwire meter up here, and of course the Ames DM1000. Now when they're all measuring the clean sine wave that's coming from the electrical utility, they should be pretty close to one another. But when the inverter kicks on and the wave shape changes, the 98674 reads way, way low. In fact, let's actually see that again. We'll force the UPS over to its battery. All of the true RMS multimeters are reading accurately, some a bit more so than others, while the poor 98674 is reading way low. So the Ames DM1000 is definitely, as expected, a true RMS capable multimeter. Here's a look at its backlight in a dim lighting situation and how it compares to the others. The backlighting is pretty good and surprisingly even, just like its predecessor. Of course, it has an electroluminescent panel behind it, rather than the edge-lit LED that the Southwire and the Aneng meters use. Let's go back to line voltage now. And once again, everybody's pretty much on the same sheet of music, as well they should be. Now let's go ahead and test some randomly selected capacitors from my innovatively named random box of capacitors. Unfortunately, I don't have anything really, really small, like going down into the picofarad range, like ceramic disc capacitors. At least I don't think I do. Let's see if I can find one in here. But I don't see one. We'll start out with some smaller ones first. I have 22 microfarads right here. Make sure I get the polarity right. And we'll just see how long it actually takes for this thing to settle out on a reading. .42. We'll try another one in the line here. The results seem pretty repeatable over the range. So these are all stuck down to tape leads because I bought most of them in bulk for an automated pick and place machine, which I am definitely not. Alright, here we have 220 microfarads at 16 volts. Now, an important thing to remember about any multimeter's capacitor testing range, they don't test under anything like full voltage. So it's entirely possible, as has been demonstrated in my previous videos, for a capacitor that fails under load to pass under a multimeter test. None of these are especially high tolerance capacitors. So we'll try another value here. We'll step things up a little bit. These are 1000 microfarad at 10 volts. These would already be beyond the range of most of my multimeters to test. And it did take the Ames Instruments unit a little while to get it done. The instability in the readings is just my slipping off of the legs of the capacitor. We'll try a third one here. All these are of the same value. Definitely needs a few seconds to settle on a stable reading. Let's see what else I've got in here. Have I got any other interesting values that we haven't tried yet? 22 microfarad, we did that. There's a 470 at 35 volts. We'll see what happens with that. Well, it certainly seems to pass that test with flying colors. I might try one or two more, but I think you've probably got the idea at this point. Oh, this is a really big one. This is 3,300 microfarads at 10 volts. And again, most of my multimeters can't do this. It certainly took its own sweet time, but the Ames Instruments DM1000 did in fact manage to test all of the capacitors I threw at it, and that is the largest one I have at my disposal. So I would say that it passes that test. So we'll move on to trying out the temperature probe. Unfortunately, I do not have any diodes handy right now, and I almost just dropped all my capacitors on the floor, which certainly wouldn't be the first time. You would have heard some very unprofessional language had I managed to do that, although I'm such a nice guy that I probably would have edited it out. Since I don't have any diodes handy, we'll go right straight to the temperature testing range. And then we'll take some frequency measurements as well. Well, as luck would have it, I actually did come across some diodes, and these represent much more of a challenge than the usual 1N4000 series common as dirt types that people would often use for a test like this, because these are some generic white LEDs, and I think these are rated for a 3.6 volt forward voltage. And a lot of multimeters, even some much newer ones where this feature would be expected to be available, can't actually pass this test. They cannot provide sufficient forward voltage or current to illuminate a blue or white LED, as those have a higher voltage requirement than other LEDs do. So we'll see what the Ames Instruments meter can do with this LED. I am pleased to see that it will illuminate it, but it doesn't actually seem to be able to indicate what the forward voltage of that diode is. Not that I am terribly surprised by that, because as I said, these are rated for 3.6 volts forward voltage, and I think the manual says that the open circuit diode testing voltage on this multimeter is only around 2.3 volts DC. But it is interesting to see that the bar graph display at the bottom is indicating somewhere in the neighborhood of 2.5 volts. Not a correct value, but at least it's trying. And of course you can tell that the diode is good because it is illuminated. Likewise, you could reverse the polarity on it, verify that it's not shorted, though it certainly shouldn't be if it lit up, because the electrical energy would take the path of least resistance. Though I certainly haven't seen every failed diode in the world, but now that the polarity is reversed, the diode is not lighting. So even if you don't get a value out of the Ames Instruments meter, you can at least illuminate the diode and should be able to ascertain whether or not it is good. This test unfortunately wouldn't be much use for things like higher voltage Zener diodes and things along those lines, which appear to be out of the realm of this meter's capabilities. I guess you could call this a bit of an unofficial vibration test, which it seems to have passed for the last several minutes that it's been going on. This can only serve to give you a very rough idea of the quality of the Ames multimeter's backlight compared to these two other models. To my eyes at least, all three of them look pretty similar, though this hold peak model on the left has the most readable numbers from the camera's point of view. It turns out that the secondary display on the Ames Instruments DM1000 multimeter does actually have a few more uses than simply displaying frequency and duty cycle readings when you're measuring alternating current. It's also used when you're operating the meter in its minimum and maximum mode to indicate the minimum and maximum readings that it has seen over a period of time. This is actually pretty convenient because it leaves the primary display active and able to display the currently indicated reading. Except for a short revised introduction to this video, everything you've just watched was recorded in January of 2018. Everything you're going to watch from this point forward has been recorded in June of 2018. Now you might be thinking that this has something to do with my misplacing the Handycam, but that's not the entire truth of the matter. I just kind of lost interest in completing the review and set it on the back burner, but I'm back, and I'm most certainly going to finish what I started. And so it is that we'll be talking about the last major feature of the Ames Instruments DM1000 Multimeter from Harbor Freight, and that is its ability to perform non-contact voltage detection. You can see there's a button on the front of the meter that actually says NCV. You can push that at any time and at any measuring range to immediately start performing non-contact voltage detection. Now, unlike some multimeters that I have with this feature, the Ames does not give you an indication of the relative intensity of a detected voltage using the non-contact voltage detection feature. Instead, it simply flashes a red light located at the top of the meter, while at the same time sounding an audible beeper. Now, it could be argued that the meters that take this a little bit further and actually try to indicate how strong the detected voltage field is are doing a little bit better than the Ames, but the truth of the matter is, if you suspect that there's a voltage anywhere around, you should be breaking out the test leads and making a proper check. I would never, ever, ever suggest that you rely solely on the non-contact voltage detection feature to ascertain whether or not there is in fact voltage present in a conductor. Some people have complained that this is pretty deaf. I would say by comparison to some of my multimeters, my other multimeters that is, it is a little bit lackluster in its capability. But if we turn it on and we hold down the button, which you have to do, it doesn't give you any indication that it's actually gone into the non-contact voltage measurement mode. But if we hold it up to an energized conductor like the cord of the washing machine, you'll see that it starts to beep to indicate that it's detected something. But the detection really does not reach very far. Back away even slightly, more than about 2 inches there, and it stops beeping entirely. Likewise, it won't detect the presence of energized conductors in this junction box, although since it is properly grounded, that makes it a pretty effective Faraday cage, so one could probably excuse it for that. If we go out here to this elderly looking wire, here again we have to be almost on top of it, but the measurement does work. Now, some multimeters that have this capability allow for you to take one of the test leads, typically the common test lead, plug it in and utilize it as an external antenna for the non-contact voltage detection feature. The Ames DM1000 does not do that. I want to apologize in advance for the utterly abysmal lighting conditions back here at the electrical service area of my home, but they're the best that I can do with what I have. I don't feel like dragging a lamp back here, and there'd really be no good place to plug one in anyway. So, we're going to take the Ames DM1000, turn on the non-contact voltage detection feature, and run it past the circuit breakers in this panel. That's a little bit hit or miss here. All of these are energized and carrying power, but it only seems to indicate anything on the last 2 of them, one of which is a standard circuit breaker, the other of which goes to the new bathroom and is a ground fault circuit interrupting type. We'll go over here to this old Bell transformer, see if it detects anything there, and it does. I don't think it'll work on particularly low voltage like the 12 volts AC that this thing puts out, and indeed it does not appear to sense anything. And then we'll go over here to the fuse panel without the cover on it, which I'm sure I'll get caned about by every electrical inspector there is on YouTube. We never had it when we moved in, and it's never been bothering anybody, so I'm not too worried about it. Turn the backlight back on. Seems to do a pretty decent job there, but again, I caution you, do not depend solely upon that test to ascertain whether or not a circuit is energized. Break out the test leads and find out, because the life you save could very well be your own. Now, with everything we've talked about so far, that probably would have been the end of this video. I would have thanked you for taking the time to watch it if you did in fact do so, and I would have encouraged you, as always, to leave a constructive comment. But as it happens, way back in January, when I first bought this multimeter, I wrote a review on Harbor Freight's website, and I tried to be very fair in my treatment of the meter. And I'm certainly not about to accuse anyone of saying that I was anything but fair in my treatment of the multimeter when I typed up that review, and I think I even included some pictures with it. At the time, I talked about the things that make it good, and I talked about the things that make it bad, particularly the issue with the flimsy battery cover and the somewhat difficult to use stand. Not too long after that, my review was published, and then a couple days later it disappeared, and I received an email from a gentleman at Harbor Freight Tools asking me if there was anything he could do to try and make things right, to give me the multimeter that I should have purchased. And so I have to give Harbor Freight Tools a lot of credit for reaching out to me and trying to rectify a situation that really wasn't anything more than a minor annoyance to start with. It does, however, say to me that they care about their customers and the experience that they have with their products, at least to my way of thinking. That's what it says. We exchanged a couple more emails, this gentleman and I, and he said he was going to try and have some revised parts made available for the Ames Instruments DM1000 Multimeter. And then, I didn't hear anything else for a long time, but like I say, here we are in June of 2018, and I went ahead and I wrote him a message just to find out if anything had changed, if anything had happened, if there'd been any movement on revised parts for this Ames Instruments multimeter. And a couple days later, I received this in the mail. This is another example of the Ames Instruments DM1000 multimeter. Now, when I damaged the battery cover on the first one, I took it back to Harbor Freight and swapped it for another. So this is not the meter that I started the review with. It is, however, a meter that was produced in very close proximity to the one that I had. In other words, I did that way back in January of 2018. So this meter has the original battery cover on it still. This is the ostensibly revised one. We'll pop it open here. And there was a copy of his business card in here. I'm not sure where it went. Oh, there it is. It's just inside the front there. Evidently he wanted me to have his contact information. The man's name is Chris Gloger. I certainly hope I'm pronouncing that correctly. He is a senior manager of product development within the Harbor Freight organization. And he has been very polite and professional throughout this. I do want to make clear that Harbor Freight has in no way sponsored or affected the impartiality of this review. It is my intention to give as fair and unbiased of a review of this product as is humanly possible. If you feel that I have or haven't done that, please let me know in the comments, and I will certainly work to address your concerns. This meter performs identically to the one on the left, which is the one that I bought with my own money and subsequently received a replacement for. In every regard. The backlight stays on for the same amount of time. All the test ranges are identical. What's changed is the arrangement of the battery cover. Now, one thing I noticed right away, and I'll have to do a little shuffling around here to show you. On the original meter, you can see that there is not only a cutout, as we talked about previously, there is not only a cutout for the magnetic carrying strap that you get, there's also an opening in the battery and rear cover assembly for it. On this replacement meter that I've received, you can see that that part's gone. The holster no longer has a portion for the strap to thread through. It looks to me like it's actually been sanded or cut off there somehow. I think you'll probably see what I mean if I bring it up close to the camera, and the camera will actually have the decency to focus, which as of late, unfortunately, it has not. But you can see that there looks to have been a very definitely handmade modification to the back of this multimeter. I'm not sure if there's actually any other difference in the back panel or not, but we'll go ahead and compare them side by side. The caution notice is missing from the replacement, but other than that, they look almost identical to me. There's a little bit of difference in how they're molded. This one's got kind of a lip on it, a depression in the molding almost, where this one's wider and flatter. I'm also curious as to what the tangs on the battery cover will look like on this variation. I will say this does not presently reflect, if you're watching this video not long after I made it, this does not presently reflect what you will probably get if you go to Harbor Freight and buy one of these meters. I suspect that if you have a problem with it and you contact their customer service, or you leave a review as I did, you might very well get this revised part, but I don't know that that's the way to bet. But we'll lift that off here. Got a Harbor Freight battery in it, just like I think mine does. We'll set that aside because I don't believe there's been any actual change to the meter itself. We'll take the battery door off of this one. Being careful not to break it. What I would hope to see here are some more robust tangs that hold the battery cover to the body of the meter. And yes, the more eagle-eyed of you in the audience have probably noticed I don't have exactly the right screwdriver for this. I'm not actually using Harbor Freight's battery. Not that there's anything wrong with it, but let's see what we've got here. Well, there's definitely some degree of difference there as well. I'll try and set these with the meters that they go with, and then I'll adjust the camcorder such, and we'll try to zoom in on them so that you can see the differences I'm seeing and draw your own conclusion about the state of affairs. I'll try to move them over a little bit so that you can see a little more clearly what's going on. Hopefully the camcorder has decided to focus. It's very hard to tell on that little tiny monitor it's got. I don't want to lose the screw that holds this on. This is the assembly from the revised meter that Harbor Freight sent me. And I do think that the tangs holding the battery cover on are a little more prominent, hopefully a little more durable than those of the other meter. I don't know if they want me to send the original meter back to them or not. Come on, focus. Yeah, it definitely looks like there are some design differences. I'm not really sure if these are vastly improved or not, because it looks like they're just barely hanging on there. And that edge looks like they might snap off at a moment's notice. But they do look like they have been revised to me. At least a little bit. So now we've reached the point where I certainly want to thank you for taking the time to watch the review. I hope you enjoyed it. I hope you got through the whole thing. Or if you decide to watch it in bits and pieces, that what you did see was certainly helpful and informative to you. And as always, I look forward to hearing your constructive commentary down in the comments section. And here, for whatever it might be worth, is just a quick look at the serial numbers on the 2 meters. This is the meter that I went out and bought and subsequently received a replacement for. There's also some kind of a date code sticker on the back of it. And then this is the replacement meter that Harbor Freight sent to me. The sticker has changed. It no longer has a date code on it, probably a lot code as well. It just says Quality Control Pass number 2, and it gives a different serial number for this meter. You can also see that the warnings and certification marks on the bottom panel of the meter differ as well. In particular, the ETL Intertech testing indication is not present on the revised meter that I received. I'm sure there are a few members of the viewing audience at this point that are probably wondering why it is I didn't include a 1 or 2 sentence summary of this meter and my opinions on it in the course of the review. And the truth of the matter is I would have done that, but I'm hesitant to do so because Harbor Freight has clearly demonstrated to me that this is a product that's still under some degree of development, and it's subject to revision, refinement, and improvement as time wears on. And I'd hate to say something in a semi-permanent record such as this video and then find out that a couple months or even years down the road it's no longer true and I've actually been misleading people by what I said. So I would encourage you to check out the description if you're looking for a brief summary of this entire review. However, I will go so far as to say that I think this is a pretty good product, and I do think it's only going to get better over time. If you're looking for a pretty cost-effective multimeter that can do a wide variety of things and also boasts the capability of making true RMS measurements for alternating current sources, this one should be on your short list of possible candidates.